This is mathheals.com, where you can go find more links to math YouTube videos and computer science. And let's take a look at an introduction to functions. Let's first write down a definition of a function. The definition of a function says, for every x, there is only one y. So for every x, there's only one y. Let's take a look at our first problem. Given a set of 3 points, instructions say determine whether each relation represents a function and state the domain and range of each relation. Well, I'm going to create a map for this. Write my x values down from smallest to largest, not repeating any. So we've got 1, 2, 3, and I'll circle each one. Then write down my y values from smallest to largest, not repeating any. So we've got 2, 4, and 5. I'll circle them. Now, this point here, 1, 2, maps 1 to 2. This one maps 3 to 4. This one maps 2 to 5. Now, for every x, there's only one y. That means for each x value, you only have one line coming out of it. And that's true. In this, we only have one line coming out of each one. So this is a function. Now, our domain is our x values, which would be 1, 2, 3. And our range is our y values, which would be 2, 4, 5. Like that. Let's do one more with mapping, and then I'll talk about a shorter way to do this. Negative 4, 1. And negative 4, negative 2. And 3, 1. I'll write down my x values, my y values from smallest to largest, not repeating any. So I got negative 4, and I got 3. And over in my y values, I got negative 2, and I got 1. Well, this one maps negative 4 to 1, so I draw a line between them. This one maps negative 4 to negative 2. Draw a line between them. This one maps 3 to 1. For every x, there's only one y. Well, see how this negative 4 has 2 lines coming out of it. So for that particular x, there's 2 different y values. So this is not a function. Now our domain is our x values, which would be negative 4 and 3. And our range is our y values, which is negative 2 and 1. Okay, now an easy way to do this. Instead of doing the mapping, if you look at it and see how we have negative 4 here and we have negative 4 here, if your x values repeat in any 2 points, then it's not a function. Up here, our x values were 1, 3, 2. They don't repeat at all, so that's a function. So that's a very easy way to do it instead of doing the mapping. Excuse me. Let's look at our third one. Got 8, 3. Got 5, 3. And we got 3, 3. Well, look at my x values. I got 8, 5, and 3. So this would be a function. They don't repeat at all. Now the y values repeating doesn't matter. We're just looking at the x values for your function. Now our domain, if I list down my x values from smallest to largest, not repeating any, I got 3, 5, and 8. And my range, my y values, for smallest to largest, not repeating any. Well, they're all 3s, so this would just be 3. Excuse me. Well, when you're working with points, that definitions works. But if you got anything more complex, for example, if I had y to the fifth minus y plus x squared minus x equals absolute value of x minus y to the third, and the question was, is it a function or not? Well, what you do is you think of an x value that causes two different y values. I could plug in x equals 1, see if it works. I could plug in x equals 2 and see if I get two different y values. I could plug in x equals 3. I could actually spend the rest of my life plugging in x values and still not know the answer whether this is a function or not. I always give the example of I pick a runner in class, and I say, "Can you run 1 foot?" And they say, "Yeah." Can I run? Sometimes they look at me like I'm making fun of them. And I say, "Can you run 2 feet?" Yeah. 3 feet? Yeah. 5,280? 1 mile? Yeah. 10,560? Whatever it is. 2 miles? Yeah. At some point, maybe at 200,000 feet, maybe 100,000 feet, they'll collapse. They can't run anymore. The fact that they can run for the first 100,000 or 200,000 feet doesn't mean they're going to be able to run forever. So the fact that I sit here and plug in 200,000 cases does not mean that it doesn't fail out at the 500th case. Well, we want an easier definition. Now, this definition doesn't work all the time. Probably works about 95% of the time, which is pretty good. That's an A, isn't it? It fails on a few, but doesn't fail. I'd say for intermediate algebra, for college algebra, this definition will work 100% of the time. It says if you have one of the following, it is not a function. If you have a y squared, if we have y to the fourth, or y to any even power, it's not a function. If you got the absolute value of y, if you got plus or minus square root of x, or actually just any plus or minus x of any form. If you have, let's see, x is equal to a number, that's not a function. Now, these don't have to be by themselves. I can have other numbers in there with it, like this absolute value of y. I could have y minus 5, or y squared minus 3y plus 2, but you get a y inside an absolute value. Okay, if I come up here, y to the fifth, that's okay. We just can't have y to an even power. Y to the first, that's okay. X squared, that's fine. X is fine. Absolute value of x. Well, we said we can't have absolute value of y. Absolute value of x is okay. And y to the third power is okay. So this would be a function. Probably. Sometimes when you make them really hideous, they don't come out as functions. Okay. Let's look at our fourth example here. We got y is equal to 2x plus 1. The question is to determine whether each equation shows y as a function of x. Well, what we do is we look for these bad things in here. And we don't have any of those in this problem. So this is a function. Yes. For our next one, we got 5x plus 2y equals 7. As I look through here, y to the first power, that's fine. We just can't have y to an even power. So this is a function. Here we got y is equal to plus or minus 3x. Well, plus or minus in some version of the x we said we can't have. So this is not a function. Let's see, number 7. We got y is equal to x to the fifth minus 1. Well, y to the first is okay, and there's nothing wrong with x to a power. So this is a function. Grab a drink here. y squared is equal to x plus 1. We said we can't have y to an even power. So the answer here is no, it's not a function. Now let's take a look at another way to determine something's a function. And it's called the vertical line test. And it says if any vertical line can intersect the graph at two or more places, it is not a function. So if any vertical line can intersect the graph at two or more places, it is not a function. Let's take a look at this graph here. Question is, can you draw a vertical line someplace that intersects at two or more places? Well, if I draw one here, it'll intersect at two or more places. So this is not a function. Number 10. Question is whether you can draw a vertical line somewhere that intersects at two or more places. Draw one here, it's one place. Draw one here, one place. Draw one here, one place. No matter where I draw a vertical line, the most it'll ever intersect is one place. So that means that's a function. Now, next thing we're going to talk about is function notation. This is a way to give your function a name. Yeah, that's good. Yeah. Usually it's not done like that. But it's fine. It'll be good. So, my wife's on cooking. Turkey. Function notation. This is has two purposes. One is to give it a name, and for example, we have y is equal to 3x minus 1, and we have y is equal to 4x plus 5. If I ask you to graph y, well, your question would be, well, which one? Well, instead of calling this y, I'm going to put this right here. And instead of y here, I'll put this. Now, how you read this? This reads as f of x. And this one reads as g of x. This is not mathematical. There's no f times x here. This is purely notation. Now, we even get lazier in math. Now I can say, graph f of x or graph g of x. You know which one I'm talking about. Now, these are interchangeable. So we'll use this for giving it a name, but if you want to go to graphing, maybe you want to put it back in terms of y. So you can freely go back and forth. Now, in math, we even get lazier. We'll just refer to this as f instead of f of x. Or we'll refer to this as g instead of g of x. Now, that's its first purpose, to give it a name. Our second purpose will be demonstrated with this example. If you remember from elementary algebra, you had problems said evaluate y is equal to 3x minus 1 for y when x is equal to 2. Well, what that means is we're going to take our y equals 3x minus 1, and we'll put a 2 in for the x. So put 2 in for the x, and that gives us 3 times 2 is 6. 6 minus 1 gives us 5. Instead of writing it that way, we could say f of x is equal to 3x minus 1, and we want to find f of 2. This notation right here says all the same words as this. So when we find this, we're going to do the same thing. Where x was, we put in 2. And we got 6 minus 1 or 5. So it's just a shorthand way of writing all those words down. Start a new page and we'll look at some examples of that. Okay, number 11. Got f of x is equal to 4x minus 1. And we want to find f of 0. Well, what you do is you go through, and everywhere you have an x, you put in parentheses first. Always do this. Always put in parentheses. Then whatever's inside the parentheses here is what you're going to put in over here. So put 0 in there. 4 times 0 is 0. 0 minus 1 gives us negative 1. B is f of 3. So again, I'm going to take my 4x minus 1, and where I have the x, I'll put in parentheses. Whatever's inside the parentheses here is what we put in over here. So we'll put 3 in there. 4 times 3 is 12, and 12 minus 1 gives us 11. Now some people, when they feel comfortable with this, they stop using parentheses. And I really emphasize that because when you go into college algebra and problems become more complex, having those parentheses there is a lifesaver. F of negative 2. Well, we'll go to our 4x minus 1. Where x was, we put in parentheses. And whatever's inside these parentheses is what goes right here. So I'll put in negative 2 there. So that gives us negative 8 minus 1. Or it gives us negative 9. And our fourth one is f of negative x. Again, it doesn't matter what you put in parentheses here. You do it always the same way. Where your x is, you put in parentheses. Whatever's inside the parentheses here is what goes inside the parentheses over here. So we'll plug in negative x. 4 times negative x is negative 4x, and then the minus 1. And that's our answer. E. E is kind of a bizarre one. It's not really evaluating a function. We got a negative out in front of the f of x. Well, we just put a negative out in front of the 4x minus 1. And remember, a negative out in front of your parentheses flips the sign of everything inside, so this becomes a negative 4x plus 1. I want to find f of x plus 2. Again, I'm going to go back to my 4x minus 1, and where my x is, I put in parentheses. Whatever's inside the parentheses here is what we put in here. So we'll put in x plus 2 there. Well, 4 times x is 4x. 4 times 2 is 8. Minus 1. And 8 minus 1 gives us 7. And that's our answer. Next one is f of 2x. Again, we're going back to our 4x minus 1, where x is, you put in parentheses. Everything else remains as is. Whatever's inside the parentheses here is what you put in right here. So put 2x in there. 4 times 2x is 8x, and 8x minus, well, that's just 8x minus 1. Our last one, f of x plus h. Well, we'll go to our 4x minus 1, where x is, when we put in parentheses. And whatever's right here go in right here. So we'll put in x plus h there. Well, 4 times x is 4x, 4 times h is 4h, then the minus 1 carries down. And that's our answers. Let's look at next one. We've got f of x is equal to negative 3x squared minus 5x plus 2. And we want to find f of negative 2. Now they say find the value of each function, but they could just say find f of negative 2. It says the same thing. Well, remember what our steps were. We go through and everywhere you have an x and put in parentheses. Everything else remains exactly as is. The negative 3 is out in front, the squared, the negative 5, the plus 2. I just replace the x's with parentheses. Now whatever is inside the parentheses over here is what we automatically put in over here. So I'll put a negative 2 in there, negative 2 in there. Then we just use order of operations. Please excuse my dear Aunt Sally. There's nothing to do inside the parentheses, so excuse exponents. Negative 2 squared is 4. And actually I'll go ahead and multiply these together. Plus 10 plus 2, which gives us negative 12, plus 10 plus 2 is 12, which gives us 0. And number 13. We've got h of q is equal to 4q squared over q minus 3. And we want to find h of negative 5. Well, again, same thing. We go through, and everywhere we have a q, in this case, we put parentheses. Doesn't matter what variable you have. Everything else remains as is. Whatever's inside the parentheses here is what goes in right here. So we're going to put in negative 5 and negative 5. Well, negative 5 squared is 25. Negative 5, negative 3 is negative 8. 4 times 25 is 100 over negative 8. I could have simplified to 4 and 8, but dear Aunt Sally tells me to do what's in top part fraction, do the bottom part, then handle the fraction. These are both divisible by 4, so that gives us 25 over negative 2. So negative 25 halves is our answer. And the end of that section.